This is day 2 of the review, number 33 through 73. First 4, you just put it into Desmos. Just type that in, get your answers. Okay. 37, these you can either use, the first couple here are just kind of looking at different properties where you can actually kind of work out these properties. So we want to know what this is equal to. So I'm going to say it's equal to x and find x. So I know that 13 to the x equals 1, and I know that any number to the 0 power is equal to 1. I know that ln works cancels this out, so it's just going to be the square root of 6. If you actually work this out, if you want to work it out, it's the same as this, right? So you could say e to the x is equal to e to the square root of 6. So you'd get x is equal to the square root of 6. It kind of proves that those cancel out there and why that happens. Here as well, we had a property that said those cancel out, you just get 12, or if you actually write it out, you know that 5 raised to the x is equal to 5 to the 12th, therefore x is equal to, x has to equal 12. Okay, number 40, there was another property that said these kind of cancel out and you get x is 13, but this is the reason why. If you write this as a log, this would be log base 7 of x is equal to log base 7 of 13. So by looking at that, I know that the x has to equal the 13. Same idea here with this one. Okay, you could just know those cancel out. You get x equals 5, or if we write it as a be log base 3 of my x is equal to the log base 3 of 5. So they're both log base 3, so I know that x has to equal 5. If we rewrite this as an exponent, I know that 4 to the x power is equal to 64, and I know that 4 to the third is equal to 64. Or if you get the same bases, this would be 4 to the third. Okay, so you know that x has to equal 3. Okay, 43 started some matching. And notice these are all...
So for this one, because of the histogram, right, there's...
Okay, so with all of these, they're all log base 2. So our parent function, log base 2 of x, is this one. Okay, so it has an asymptote right here at 0, and it goes through at 1. Okay, so there's my base function e. Now compared to this one, that's 2x. Okay, so... we didn't really talk about a whole lot what happens when it's on the inside like this, but if you graph this, you could use it on Desmos. Basically, it's the vertical stretch, okay? And you can see how this one compared to this one is stretched vertically a little bit more. Okay, so D. 45, 1 over x is the inverse sort of idea. Okay, so part B. 47, instead of stretching, it's compressing. Okay, so you can see here that it's compressing it down a little bit more compared to this one. 47, I know this is moving to the right, so instead of here, it's moving to the right one. And this one is a reflection, okay, over the y-axis. So instead of here, it's going to be reflecting over the y, which is choice A. Right, you can always look at those on your on Desmos also to make sure those are correct. Okay, for 49, 50, and 51. I want to find the domain and range, so you want to get a graph on Desmos. Okay, so I graph these here. Remember that the log functions always have vertical asymptotes, whereas the exponential would have the horizontal ones. So log functions, log base e, right, have vertical asymptotes, and log functions have vertical asymptotes. Okay, so our domain here would be from 0 through infinity, and our range goes all the way up and all the way down. Natural log here starts at 2 because it gets shifted this way, right? To the right 2, so 2 through infinity. And all the way down, all the way up. Okay, this one here looks like this, so it goes from -infinity to 0. And all the way down, and it'll keep going all the way up. Okay, number 52, if you look at your homework from yesterday, if you compare these graphs to the other ones, they are inverses. Right, so if you think about the other ones, it's just that reflection across the line y equal x, right? So compare the other ones from those other one from the day before to this one, and you'll see that reflection idea. Okay, next one, we want to know what is the base of the logarithm. Okay, so we're thinking here log of what base. Okay, we got to put these in here. Equals 4 of 81. Okay, so I kind of think to myself here, I'm going to rewrite it as an exponent then. So x to the fourth is equal to 81. So I know that 3 to the fourth. Okay, so it'd be the same as 3 to the fourth. Other way around, exponential would include this. And it says what is the base of the exponential. So I know that what is the base is equal to y, and this would be my exponent up there. So to work this out, if I rewrite this, this would be 2 to the negative 4. This is 2 to the fourth, and bring it up top to be negative 4. So that x has to equal 2. Okay, number 55, I can use the quotient rule. So I know this is going to be log base 3 of mn minus log base 3 of 5r. And I can take these and I can separate these using the product rule. So this would be log base 3 of m plus log base 3 of n. This would be minus log base 3 of 5. And it would be plus, but I've got to take this negative 3 to that, which makes it minus log base 3 of r. Number 56, quotient. So log base 2 of the square root of 7 minus log base 2 of 15. And square root of 7 I can write as 7 to the 1/2. So it's the same as log base 2 of 7 to the 1/2. And using the product rule, you can bring that 1/2 out front. Okay. Okay, 57. These are being multiplied, so you can use the product rule. So I can say this is log base 5 of x squared. Product is plus log base 5 of y to the fourth plus log base 5 of the fifth root of m to the third p. Okay, using the product rule here, I can put the 2 out front and put the 4 out front here. Okay, now this one's a couple steps with this one. So this is the same thing here as m to the third p raised to the 1/5, right? Okay, so if I distribute that through, that would be, I'll write it down here, log base 5 of m to the 3/5 and p to the 1/5. Okay, multiplication here, so I can separate that as well. Okay, bring this log base 5 of m to the 3/5 plus log base 5 of p to the 1/5. And I can use the product rule here. Okay, we're actually minus now, right? Because it's negative 3/5. So and plus 1/5 log base 5 of p. It's a long one. Okay. Next one here, since we can only take the log of multiplying and dividing, not of adding. So properties do not apply. We can't simplify that. 59 asks us to first solve it analytically. So I'm going to use the quotient. So this will be the same as log of x plus 3 over x equals 1. And to solve this type, I'm going to turn it to an exponent. Okay, so I know it's going to be 10 to the first is equal to x plus 3 over x. 10 is the same as 10 over 1. If I cross multiply, I have x plus 3 is equal to 10x. And subtract that over. 9x equals 3, therefore x equals 9 divided by 3 is 1/3. But that's not correct, because you pick out my mistake. Because plus is not the quotient. Plus is the multiplying. Okay, so I have that. So then it's the same thing as log of x squared plus 3x. Okay, and now I'm going to use that base 10, right? So 10 to the first is equal to x squared plus 3x. Get it equal to 0. It's a quadratic. And factor. You get x equals negative 5 and 2. Okay, log functions, remember, they don't go negative. They have an asymptote at 0 and they're positive, so this one won't work. And if you go to your graph and graph this, the graph looks like this. You can see that the answer is 2 right there. And there's an asymptote here, right? So So you can see why -5, there's no answers down here for -5, it doesn't work down there. Okay, so I want to know where is it greater than 0. Okay, this is where it's equal to 0, greater than 0 would be these, so from 2 through infinity. Number 60, we know that natural log and e cancel out, so I just have natural log of x minus natural log of x minus 4 is equal to the natural log of 3. Okay, so we're going to have natural log on both sides. So I'm going to try and get natural log just together. Okay, so now it's subtraction instead of addition. So it's going to be use the quotient rule. Okay, so now I know that they're both natural log. I can say that this has to equal this. You know that x over x minus 4 has to equal 3. Same as 3 over 1. Cross multiply. X is equal to 3 times x minus 4. X equals 3x minus 12. 2x equals 12, therefore x equals 6. If you graph this, it confirms it. The graph looks like this, and it intersects here at 6. Okay, and we want to know where is it less than or equal to 0. So here's 0, these numbers are less than 0, so from 6 through infinity. Oh, careful though, because it says we're equal to, so I need to go to this. Okay, so 6 through infinity. Okay, if you remember 61, ln and e cancel out, so I just have natural log of 2 minus natural log of x minus 1 is equal to natural log of 5. Minus is quotient rule, so 2 over x minus 1. So I know that this 2 over x minus 1 has to equal 5, which is the same as 5 over 1. Cross multiply and distribute and add and divide 7/5, okay, which is the same as 1.4, and you'll see that in the graph, and it looks like this, and it crosses right there at 1.4, which is the same thing here as 7/5. Okay, so we want to know where is it greater than 0. Greater than 0 would be right here. Remember, there is an asymptote right here though, right? So it's only between 0, I'm sorry, the asymptote isn't there. The asymptote is at 1. So it's not at 0 because of this, right? Okay, so we have an asymptote at 1. So it goes from 1 to 1.4. It can't equal at 1, but it can equal at 1.4. Okay, these first two, I can do these by getting the same bases. So for example, this is 2 to the 3rd is 8, and 2 to the 5th is 32. So I know that 3x has to equal 5, therefore x is equal to 5/3. Okay, this would be 2 to the 3rd and 3 to the 3rd, right? So that's the same thing as 2/3 to the 3rd. And if I want to make this, you can go 2 different ways, but if I want to make this a negative, I can just put the 3 on the top and 2 on the bottom, right? So therefore, I know that x has to equal 3 over 2. With all these, you can always check yourself on your own Desmos either, see where it's equal to 0. Okay, now this one, I can't get the same basis because we got 10 and 17. Won't work. So remember how we have to take the log of both sides. Okay, and we can use the power rule to bring that out front. Okay, take this and distribute it. So this is just a number, right? We're going to take that and distribute it through to that. So we have 2x times the log of 10 minus 3 times the log of 10. Okay, to get x by itself, I'm going to add that over and then divide by this stuff here. So I know that 2x times the log of 10 is going to equal the log of 17 minus 3 log 10. Sorry, add it over, right? Add that over to this side, 3 log 10. And then I'm going to take x by itself, I'm going to divide by the 2 and the log 10. So x is going to equal this. Divide by 2 log 10. And if you put that in your calculator, that is approximately 2.115. You could also simplify all this. On a test, I would be okay if you saw it like this and leave it like this. But you know, let's do it. So If I take this 3 and make it up here, use the power rule and the 2 here as well, this would be log of 17 plus log of 10 to the third over log of 10 squared. Okay, so I have the same bases, and I can, well, adding is same as multiplying. So we log of 17 times 10 to the third over log of 10 squared. (17 times 10 to the third). We could work that out. Would be the log of 17,000 over the log of 10 squared is 100, which is log of 170 over. You know what? Just leave it like this. We're good up there. So don't worry about doing any of this stuff. For our purposes and what we're doing in this class, we'll just leave it as that answer right there. Right, 65. 65 and 66. Okay, whenever you see the e, we're going to take the natural log. And e and natural log cancel, so I just have x plus 1 is equal to the natural log of 10. And lastly, to get x by itself, just subtract your 1. And let's see, if I put that into decimal form, it's approximately 1.303. Okay, when it's just a single log, let's turn it to an exponent. So the exponent would be 64 to the 1/3 equals x. And 64 to the 1/3 is the same as cube root of 64, which is 4. 67, we have natural logs on both sides, so we're going to try and get this to a single one and set them equal to each other. So with subtraction, we can use the quotient. Okay, so now we have them single ones, so I know that this 6x over x plus 1 has to equal 4, which is the same as 4 over 1. Cross multiply, 6x is equal to 4 times x plus 1. Subtract that over, and divide. Number 68, I have one of these logs I want to combine together. So with the plus, it's the product rule. So it's 2x times the x minus 1. So this would be log base 12 of 2x squared minus 2x. Okay, remember when we only have log on one side, I want to change it to an exponential. So I'd have 12 to the first power is equal to 2x squared minus 2x. So we have a quadratic to solve. So I'll subtract that 12 over. I'm going to divide a 2 out. And I get x minus 3 and x plus 2. Therefore, x equals 3 and negative 2. Set that equals 0, there's no x to solve for, right? And as part of when you're talking about log functions, they don't go to negative, so we have 3 as our only solution. Okay, sorry, I thought I hit pause and anyway, messed up the video, so here we're going to pick up from here. So 69, we have this equation here. We can just change it right to an exponent, so 16 to the 1/4 is equal to the square root there. 1/4 power is like the 4th root. 4th root of 16 is 2. I can square both sides, so you get 4, and that takes that away. Subtract your 1, you get 3. Number 70, first thing I want to do is take care of this. Use the power rule to put that 3 up there. 2 to the 3rd is the same thing as 8. Then with addition, I want to use the product rule. So it'd be natural log of x times 8. Now it's the natural log of both sides, so I know that 8x here has to equal x divided by 2. I like to get x over 1, I like to cross multiply. You get 8x squared is equal to 2. Divide by 8, you get 1/4. 2 over 8 is 1/4. Take the square root of both sides, you get plus or minus 1/2. But if it's just a regular natural log, remember our domain stops, or we have an asymptote at 0, right? So 1/2 would be the only answer there. Okay, 71. Natural log and e cancel each other out, so I just have a negative x there. Since they're both natural logs, I know that negative x has to equal 3. Therefore, x equals negative 3. 72. These cancel, so I just have x. These cancel, I just have the 3. These cancel, I just have the 5. Add your 3 over, you get x equals 8. Okay, 73. If you take the log of both sides, because I can't get equal bases, log of 2 to the x is equal to the log of negative 3. This is undefined. You can't find the log of negative 3, so there is no solution to this. Another way to think about it is if you had just turn this right to a log function. So this would be log base 2 of negative 3 is equal to x, and you can't take the log base 2 of negative 3, right? So it's no log base 2 has a graph that looks like this, right? So it's undefined over here at negative 3. There's no solution to it. 74 and 75, I just noticed that's for tomorrow's homework.